Well, hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at this monitor. This is a Hitachi VM-129U from January 1984. I think it was originally designed to be a security camera monitor, so it's built like a brick house, a brick blank house, you know what I'm talking about. All metal, outside chassis, this front bezel is plastic. This thing has seen, well, it's seen better days. I think I might have had this on the channel before, but I'm not 100% sure. It originally had a white CRT. As you can see, it's green now, and it's a 12-inch CRT in size, hence the model number 129U. What I really like about this monitor is, well, it's sturdy construction, but it's also incredibly sharp for a monochrome monitor. It's hooked up to an IBM PC clone here, and it has extremely sharp display. So let's see, trying to rig up something that will show off the sharpness. Exit out of that, whoops. Pushing buttons like crazy. 4, crosshatch. Yeah, that looks really good. And we're looking at 640 by 200, because of course this is over CGA, composite video that is, from my PC over there. And what I really like to do on today's video, well, there's a couple things. I want to see if either one of these CRTs that I have here will work inside of here, because both of these are white, and I'd rather have a white phosphor CRT in here than green. I don't know why, I just feel that like these security camera monitors, because they always were white phosphor originally, they look better when they are running a white phosphor CRT. And these types of monitors would definitely be paired with machines like the Apple II or really any other early 80s microcomputer. Back in the 1980s, it wasn't like there was a plethora of choice for computer monitors. I mean, now you can go to anywhere and you can just buy any kind of computer monitor you need. But in the early 80s, that was not common. So early days, people were actually using security camera monitors because they offered a very, very sharp display. I don't know if they were reasonably priced, but at least they were something that was available. And compared to a television, which was super low resolution comparatively, these were great. And also, of course, unlike a television, these had composite video inputs. You didn't need to use the RF connection on whichever microcomputer you were using. So these were definitely a luxury item. And the 9-inch versions of these were a little bit more common because I think they were just cheaper than the 12-inch versions. So if you had one of these, you were kind of a baller, I suppose. I'm not sure when Hitachi started making this particular model, the VM-129U, but from the service documentation I was able to find, this thing supports 700 lines of horizontal resolution. Now, because it's a monochrome screen, there's no phosphor, CRT, mask, anything like that. So ultimately, the resolution is a factor of the cathode drive circuitry that's on these, and these were just designed to be really sharp. And I guess if they were going to be used with security cameras, monochrome security cameras, they wanted to be as clear as possible for the best hope of seeing the perpetrator stealing your whatever, something. Now, I know I swapped this CRT into this set in 2023. I put a note on the back, but I wish I had made a note of the type of mounting ears the CRT needed to have to go back into here. I'd always hoped I could find a white phosphor CRT to put in here, and that's why I have these two that I've had sitting around. And I just want to see if either of these are going to be good candidates. I have a surplus, so to speak, of green phosphor ones. Just don't seem to have the surplus of the white ones. It always feels like when I get a monitor that's got white phosphor CRT that's 12 inches in size, there's something wrong with the CRT, like it's got the cataracts, or it's burned in really badly, or just worn out, or whatever. So I think at least this one over here on the left is in decent shape, and I'm hoping it's a good candidate to go back into here, and that will bring this thing back to its, proper white phosphor. And while I'm at it, I should be able to maybe adjust some of the settings internally to, for instance, shrink the image a little bit, because it seems to be kind of going off the edge a little bit, plus it's curving out a little bit. So maybe with these little magnets on the yoke, I can correct the corner geometry and just try to get this thing working a little bit better. There's one other problem with this monitor that I want to demonstrate, which I think is something that's potentially fixable as well with the setting inside the monitor. So the image you see on the screen is called the multi-burst, and it's just showing off the resolution of the set. So even at this area where we have alternating white and black vertical lines, it's still resolving that relatively well. So this is where having a high resolution monochrome monitor really comes into play. So 80 column text on this thing looks absolutely fantastic. Now the problem I want to demonstrate here is not really the geometry issues, which you might be able to just sort of make out a little bit. The corners kind of curve that way a little bit. That's correctable, and plus the centering's maybe not quite perfect. The issue is this thing suffers from a DC restoration problem, or lack thereof. What that means is when you have an image on the screen that has a lot of bright content, like what we're looking at here, if we look in the border region, this is just black. There's no visible scan lines at all in there. Now, if I turn out the brightness, I can see the scan lines that are visible there in the black area. And this is a monochrome image, just white and black. So therefore, we shouldn't be seeing any scan lines. Well, if we just turn down the brightness, so now I don't really see those scan lines, we just see the image. If I exit out of here and I go to something that looks mostly dark, like this, well, now those scan lines are visible again. And the problem is if I turn this down, so those scan lines aren't visible anymore, the image looks good now. If we go to something like color bars, what's happening is we're missing some of these shades of gray, or green in this case, that we should see. Now, if I turn up the brightness again, you can see there's actually a column there that is invisible because of the adjustment. But see, I adjust that so it looks good, like that right there. Well, now we're going to have that same problem. Even on this screen, I can now see the scan lines up in the black area at the top. This is the lack of DC restoration. That means that depending on the content of what you're displaying, that changes the overall brightness or black level of the entire image. Let's check out high voltage regulation. Okay, could really exacerbates the problem here. See, the scan lines are not visible there, and then as it goes away, now they are. So there we go. You can see this, it's kind of got, that should be black, the background there, and clearly that's not. And that's that DC restoration problem. Now, this monitor appears to have a switchable DC restoration function on the inside. I don't know if it's engaged or disengaged. If it's engaged, well, it doesn't work very well. But that might be, unfortunately, as good as it gets. But to be honest, I feel like it's not turned on, but I just don't know for sure. And if you were displaying this on a really cheap black and white television that doesn't have DC restoration, I think it would be even worse. So maybe this does have DC restoration and it's just not a very effective circuit. That's what I'm going to have to take a look at inside. Exiting to MS-DOS, let's just take a directory listing here. The text is extremely sharp. It's extremely sharp. It looks really, really good. Let's go into edit, MS-DOS editor that is. Look at that. Pixel perfect. You can make out all the dots on the scroll bars. The text is incredibly sharp. If I were using a computer back in the day and I had this monitor, I would be extremely happy with the way the text looks. Now that whole DC restoration thing probably is not that big a deal. And to be honest, using this on something like an Apple II, you might not notice. But here's an example. In this editor, the background here is actually, well, it's blue on a color screen, but it should be sort of shaded. And then the drop shadow on this window should be black, and I can just barely make it out. But if I turn the brightness up, now it's much more evident. Now, let's see here. I guess it's just very dark, because if I turn it up too much, then I start to see the scan lines there. And we do have the contrast knob we can fiddle with as well. Either way, this green CRT that's in here is very sharp, very strong. It's not worn out whatsoever. And that's what I'm hoping the white CRTs are, because if it were worn out, around the bright parts of text, like where it says untitled there, that would be hard to read, and it's completely easy to read right now. And all the text is massively sharp on this green CRT. So as I mentioned, I really hope that one of these is in decent shape. It looks like I wrote here emissions 1.1 at 300 volts G. That's the voltage for the grid. I've obviously tested this one, but this one I have not tested, so I have no idea of the quality of this one. Now, I do know that this one, considering I haven't even ever turned it on, I know it is a white phosphor CRT because I have a little UV flashlight. This is, what, 365 nanometers? You can get these from eBay, AliExpress, something like that. Yeah, I'm pretty sure this is 362 or 365, something like that. Either way, what's cool about it, if we turn this thing off and take this flashlight and we shine it at the screen, well, it's kind of got a greenish tint of phosphor here. So that tells us, obviously, this has a scratch in it. Wow, I didn't even notice that. This has an actual scratch in the glass right there. Anyways, it's obviously very minor. I never even paid attention. But yeah, this flashlight results in a nice green image. If we take a look at this one that's sitting on top, we get a bluish white. So this is a P4 phosphor image. I think this one came out of a black and white television. So this may not be very suitable for this particular high resolution set. I don't really know what does the CRT itself have to do with the resolution? I'm not sure. I thought it was really the cathode drive, but maybe there's more to it than that. This one, on the other hand, came out of a computer display. And if we look at this, it's got, oh, flashlight's kind of dying. There we go, bang on the table. That's got the same P4 phosphor. So kind of a lightish blue color. So I know both of these are white, and that's even without turning them on. All right, first things first, I'm gonna open up this monitor, which you should never do unless you know how to do so safely because there's high voltages and stuff in here. So I'm gonna open this thing up, take it apart, and see if these two screens are gonna fit in here, and hopefully they do, and then I can swap them in, we can see how they work, and then I can try to adjust this thing and make it look better than it does now. Now, just in case, I'd never shown this previously in the past, the back of this monitor, you can see it's all metal construction. I added this video input jack. It originally had these screw-on coax type jacks, so I added a regular RCA. It's just, I have an adapter to use, it's just a pain. So rather have an RCA. Swapped in green CRT November 28th, 2023. Video monitor VM-129U, so this is a North American market, that's the U there. And there is a date, yeah, like I said on the intro, January 1984. Now this particular monitor, I remember one thing about it is, I think it was exposed to a whole lot of water because there's actual, like, I think this is powder coated, the metal case, and there's bits where it's bubbling up. So I think there's rust forming on the metal chassis. And that's on the top and on the back, and I think on the inside there's quite a bit of that. But it's such thick metal that I don't really think it's that much of a problem. And cosmetically on the outside, it's not that big a deal either. So that's why I've just sort of never done anything about it. Maybe at some point in the future when I have a lot of extra time, which I don't have now, I'll sand this down and repaint it, try to take care of this. But for now, I don't really care. And interesting, it says property of International Robomation Intelligence. So it's like an asset tag from some company at some point, and serial number 7038 from their asset tag. Yes. That's the rust I remember. I should have probably tried to deal with this, even on the inside. I could just hit that with a wire wheel brush. All right, to get the front bezel off, there are two fasteners on the side, and you just pull the knobs off, and then this should come off. All right, so there's our CRT, and I think there are nuts on the front here. So I'm gonna have to get a socket wrench to get the nuts off. And I already have the neck board disconnected on the back. So this should be relatively easy to get out, and I haven't discharged the high voltage yet. Maybe what I need to do, okay, so looks like the CRT itself is attached to the top cover. So you don't wanna take the top cover off. There are fasteners along the bottom edge of the set. Set's turned on its side right now. So yeah, you don't want to take this off because the CRT is attached to that. So I think the best thing to do is leave the top cover on, take the back off, take this front panel off. Now I should be able to get that out. Now one thing I'm noticing is that the other CRTs that I have are going to work, at least physically mounting wise. There are mounting tabs on the implosion band around the edge, and they can either be mounted forwards, like towards the glass, or towards the back. And on this CRT, they're mounted towards the back, which must have been how the original one was that was on here, because this one was perfectly aligned with the front bezel. So that's exactly what I need. So I'm just gonna get these all loose. So they are still on there. So the CRT is not gonna go anywhere because I gotta deal with the connections on the back. So I gotta flip this thing around and deal with that. All right, sorry it's a little hard to see just because it's dark inside there, but the CRT neck board is off, like I said. There should be a way for me to unplug the deflection yoke. Oh, that just came off super easily. In fact, what I'm gonna do is while the CRT is still mounted, I'm actually just gonna unscrew this clamp and slide the deflection yoke off. And that's because I'm gonna have to transfer it over anyways. Now, interesting is this one has little spaces for the magnets that can correct the corner geometry, but there's nothing actually there. So I'll transfer them off one of the other yokes that are on one of the other CRTs, and that will allow me to correct that bent-in corner geometry. Now I do need to discharge the CRT, and to do that I'm going to use my high voltage probe. This is actually in focus, so I'm in manual focus, so it's not hunting. There's the high voltage probe. The CRT is not running, of course. This thing is designed for measuring the running voltage while it's turned on, but it's off. So it's perfect to just discharge it. So you clamp it onto the ground lead, and you just get this underneath high voltage anode cap. And there is nothing. This thing actually discharged itself. This CRT had a discharge resistor built into the circuit, but you can't rely on that, which is why you always have to discharge it manually. Okay, so this thing is all ready to go. I'm just gonna tuck the high voltage connection up and out of the way. I'll get my probe disconnected, and I'm gonna flip it around, and whoops, that didn't stay. I'm gonna have to get creative and two-handed when it comes to trying to get this out, because it looks like it goes forward. So yeah, the CRT does go forward. Oh, I got to unplug the ground strap off the CRT. That goes to this little neck board there. Okay, now the CRT is ready to go. So now, because I have those nuts almost off all the way, I'll just get them off the rest of the way. And there is the CRT. Right there. And the one that was in here, it was an Ampex 31-334GH. I dropped the nut. I'm going to pick that up right now before I forget. So there it is. So there's the CRT. I have the emissions written as 1.0, which is actually lower than that other one. Anyways, I got to get this ground strap off. I'm going to have to transfer this to the other CRT. To do that, it's got a spring here, so just have to kind of hold on to the set or CRT. Got a little bit of a shock from it just there. Yep, so there's our ground strap. We're gonna have to transfer that onto the new one. And here are the mounting ears I was talking about. There we go. So either forwards towards the glass, the front glass, or towards the back. This thing uses it towards the back, which happens to be what those other two CRTs are as well. So this being an Amperex, sorry, I said Ampex earlier, Amperex, this is definitely from a computer. So this is a high-res CRT, I mean, designed to be, oh, I wrote G1, 300 volts, A+. Kind of my ratings. If I ever test one of these, I'll write that on there just for my recollection. All right, well, let's start with this CRT. Who makes this? I don't know. It's a 12 VCM P4. Is there an EIA number on here? No, I don't see it. Anyhow, it's from a computer. So this is what I was talking about, those little magnets. This has 3 of them on there. So I could take these off and stick them on the other one. I have no idea if this deflection yoke is going to be compatible with the one that was on here. I don't think so. So I'm going to transfer the one that's from this monitor over. It's in good shape, luckily. No corrosion or anything like that, even though the rest of the chassis is in such bad shape. So I got to get this off. I'll just use this flat blade screwdriver here. I forgot where I got this CRT, but there we go. Deflection yoke on it. Seems fine. There's a bit of something there. A little bit of like glue or epoxy or something in there, but none of the windings look corroded. Sorry, it was out of frame there. That's what's important. So let's transfer this deflection yoke over, the one from the Hitachi monitor. This has actually an adjustment here. See this thing? This is probably a width coil. Anyhow, let's see. I don't know which way this should go on, so I'll just put it somewhere and tighten this to some extent. I will have to make adjustments later. Installation is reverse of removal. So I'm going to put the high voltage anode this way, facing up, which I think is the way it was originally on this monitor, because the flyback is on the top side. And we'll just get this over these mounting lugs. And I'm going to thread on some of the nuts on here just so it holds on. It won't go anywhere. I don't need to tighten it yet. I just want this thing to not fall on the ground. It's not like these CRTs are available to buy anymore. So what's on the planet right now is all we're ever going to have. Oh, what did I forget to put on, everyone? This. It's not going to work without that. All right, let me get this off. Put that on now. Now, you might be asking, why am I not testing these first? The problem is, I find that the tester is just so inconsistent. And the reason why is I'm sure it's very consistent if you test one CRT of the same type against another, and you can say, hey, this one's better than that one. The problem is, it's not really good when you test one CRT against a different one that's a totally different part number, brand, all that kind of stuff. That's where it doesn't work so well. So when you put the strap on, you have to make sure it's touching this dull gray part. Right now I have it going across the sticker, so maybe I should put it from this corner to this corner. That way it's on this bottom part. It has more contact area with the actual dull part of the CRT. You obviously don't want to have it go right across the high voltage anode connection. So you would not want it to go from this corner over to that corner, because it would go right over this. You can have it do that as long as it's on the bottom side here. So there we go. Now it's just on the dull black part, and that should work. So back into the case it goes. All right, first off, high voltage anode connection. Now with it on there, you want to give it a little tug, make sure it's not going anywhere, and it's not. So now I can connect up the deflection yoke. One thing you have to always do is connect the ground lead to the neck board. That is imperative. There's a ground lug for it to connect to. Sometimes it's soldered on, but do not operate the set ever with that disconnected. That would be bad. This is the switch, as far as I'm aware, for DC restoration. Now, generally, when it comes to CRT swaps, if you're in this time period, 80s, the CRTs are all of the same size. If they physically are the same size, they're generally going to be interchangeable. 12-inch sets, at least the foreign-made ones, which not North American made like this one. I think by this point, everything was pretty much foreign-made. Pretty much, they seem to be fully interchangeable with each other. Okay, well, high voltage is connected. Deflection yoke is connected. We have the ground lead connected. I think everything is good to go for testing here. So I'm just going to turn this around. I'll just leave this on its side this way. It doesn't really matter. Having it on its side just makes it a little bit easier for me to access and plug things in, which is why it's on its side. So plug that in. I got to plug or get the video cable connected up. I'm going to turn the brightness and the contrast all the way down, which is what I just did. And here we go, 3, 2, 1. Let's see, is the LED on? Yes, it is. So the set is running. Yep, there's high voltage. I can feel a little bit of static on there. Let's see here. This is the brightness control. Oh, well, I obviously have the deflection yoke turned the wrong way. But there it is. Okay. This CRT is not as good as the green one. It's definitely a little bit more worn out. I'm going to turn this off so I can fix the orientation of the yoke. All right, let's see now. I think I might have flipped it the wrong way. We'll find out shortly. Now, the reason why I'm saying this is not as good as the other one is... oh, it's upside down now. Okay. The reason why I'm saying that is it just seems that... Okay, actually, I don't know. Maybe I take that back. Maybe it is really good. I mean, it looks good. And who knows how long this has been since it's run. So maybe it just needs to kind of warm up, which I've definitely found that's the case sometimes. Let me fix the deflection yoke one more time and rotate it around. 180 degrees, everyone, 180 degrees. Incidentally, one thing about this chassis is it has a large transformer. So it's an isolated design. It means that the 120 volts comes in, it gets turned into whatever, 18 volts or something like that. Probably runs on a B plus of 14 to 12 volts. And there's a regulation circuit on the main PCB, and then that's the whole set that runs off of it. Okay. Yeah, I mean, this looks pretty good. I remember how this thing was originally, and it was bad, everyone. It was so worn out. The original CRT was burned in. It was blurry. It was just horrible, but I see nice, sharp scan lines. That looks good. That looks freaking good. Okay, let me turn off this light here. And so we can take a look at this DC restoration situation that I was talking about. And I'm going to put this on manual focus because this camera has a tendency to really zone in on my hands if I go put it in front of the set. And it's kind of annoying, the hunting. Okay, so we see scan lines there. So if we turn the brightness down so you do not see them, this control is the brightness control. So now they are not visible. The ones that are right there, we can turn the contrast up a little bit. Looks really good, actually, really, really good. As soon as I got rid of that help screen, now we can see scan lines again. Well, I can at least. And I bet you if we exit out of this, yeah, I may clear the screen, like, see how visible the scan lines are now? That's what I'm talking about. So I'm gonna try to flip that switch that's on the neck board, the one I pointed to earlier. Okay, I just flicked it to the other position. Let's see if that makes a difference. Okay, it is way super washed out and bright. So I have the brightness turned all the way down. Let's see if it has DC restoration or not. Okay, well, there are some controls on the neck board which I think are for like sub-brightness and stuff. I'm gonna have to turn those because clearly, where are they? Oh, they're kind of out of reach. I'm gonna have to go on that side of the set. Just making sure that's in focus. Okay, I'm on this side now because the controls on the neck board are facing this way. So it's the only way I can really adjust them. There are two of them. I don't know which is which. I don't feel like touching those with my bare hands, so I'm going to use this little plastic tool here. I'm going to try to at least. Okay, actually, I can't really get my tool in there just because the case is in the way, so on goes a rubber glove here. Okay, the first one might be focused because it doesn't really do anything. The other one, well, that doesn't really do anything either. Interesting. Yeah, definitely the top one, the one that's close to this side, that's focus. Well, what kind of a weird control is this? That's probably why I never adjusted it, because it looks like this, all mega washed out. And I can't really get this thing back to looking okay with these controls. I'm gonna go to the service manual. Let's take a look at the service manual, see what's going on with that switch. All right, so this is the service manual. CRT2, this is on the back of the CRT. Sub-brightness control, VR5 or VR151. This is on the 906 and the 129. This set is the 129, okay. Adjust only when DC clamp switch is on. Set bright control to maximum and contrast to minimum, and then adjust raster is slightly observable. On switch for DC restoration circuit. In standard sets, the switch has been preset as follows. In the 129U and C, it's off, but in the E and K models, different markets, it is on. And the 9-inch is slightly different. But it's so funny because that sub-brightness control doesn't really seem to do anything in this thing. And then there's focus control, set brightness controls to normal operating positions. And yeah, the focus control was the other one that was on there. And yeah, it does say you use adequate care when adjusting because approximately 350 volts is available at this control. That's why I was wearing these pretty thick rubber gloves here. So in a way, I feel like there's something wrong with this switch. It shouldn't result in the image being super massively bright. DC clamp on or off. Adjust the sub-brightness only when the switch is on. But that sub-brightness control, it didn't do anything. Okay, so this is the little board. I'm sorry you can't really see it, but there's that control, and it is labeled switch 151. This one here, closest to it, is sub-bright, and the one that's on the other side is focus. Focus control definitely was working, but sub-brightness, well, I mean, it was working, but not really. So it feels like there's something wrong with this board. And I must have fiddled with that in the past, and that's why I left it in the off position. Is it labeled on or off? It's currently, well, it's really hard to tell from the picture which way is on and off. And it doesn't say on the board which is on and off. Like with the switch towards the sub-brightness, is that the on position? Because looking at this, it's like on is towards the sub-brightness control. So I guess it's currently in the off position. I don't know. I'm gonna put some contact cleaner inside that switch. Just, it's only a three-position, or three-prong switch, but let's do that. So that switch has two positions. The thing is off right now. So one is towards the sub-brightness control, that's on, and down towards the inputs is off. So I'm gonna put it in the on position, and let's see what that makes this thing look like now. So in the on position, it actually looks okay, the image. Now let's see if that sub-brightness control actually does anything. Okay, with that switch in the on position, it actually does something. So now if I turn the brightness, I'll turn the brightness all the way up. I'll turn the sub-brightness control all the way down, which is what this is there. So I guess my confusion is if I switch off that switch, we turn the brightness control all the way down, and I turn that switch to the off position, which I'll do right now. The image is super duper blown out, and the sub-brightness control, which is all the way down, and so is the brightness control, is super bright still. Let's switch the switch to the other position, the on position, and now, okay. So there we go, no scan lines visible, just text. And if I do edit, I mean, it's definitely too dim. So I gotta turn the brightness up a little bit, like that. Let's just get it just right. Okay, no scan lines visible on the edge. The image looks good. But yeah, as soon as I clear that away, now there's scan lines. There may be no way to fix this monitor. This might just be the way it is. And it might have always been this way, who knows? If you're not looking at stuff with gray shades or shades of gray, then it's not that big a deal. Like if you were using this with an Apple II, because you could just turn up the contrast and just sort of deal with it. But unfortunately, it just means that this circuit is just a little bit ill-suited for use with computer monitors. Because computers obviously have like wildly changing things where you might have like mostly black with a little bit of text or lots of stuff on screen. And that's just kind of par for the course. Now, I do have to say that I think this CRT is a little bit worn out compared to the green one. That's just because when there are bright sections, like where it says untitled there, the scan lines are kind of blurry. And I think if we go to that CGA compatibility, or sorry, what am I in here? Oh, vid test. It's funny reading the text sideways. It's just kind of strange. Vid test, if I can spell it correctly. Yeah, that doesn't look super sharp right there. I mean, maybe if it was not on its side. Let's see, which one do I want to look at? Well, 9 color, no. It's just not as sharp as it would be, I think, with the green CRT. That looks good though. Looks pretty good. Let me adjust the focus control carefully, of course, because it's got 300 volts or whatever, right? It's a compromise between focus in the middle versus the edges. So you got to look kind of on the edge, look in the middle, the scan lines, and just kind of get it where it's good on both. Like that. That looks good. Okay, back on the service manual here. I just want to see what kind of adjustments we have on the actual PCB. So that's the front controls, vertical hold, blah, blah, blah. There's a horizontal frequency, a vertical height. Then we have B+, and a width coil. Width coil is towards the back. I gotta look to see if that's there. Yes, I see the width coil. Yeah, I see the width coil. And you have to use a plastic adjustment tool like this to bring it in because you can't stick metal into a coil like that. So let's see if, I don't know if this is gonna work or not, but let's see if it does. Yeah, I'm in the coil right now. So if I turn it counterclockwise, it's getting narrower, which is actually what I want. Okay, and there's that other coil on the deflection yoke as well that definitely will bring that in. Just move the camera a bit so you can see that I did bring in the size a little bit. There's more visible, at least on the bottom. Let's check on the coil on the yoke. Can I get this tool in there? Same tool. Yep. See what this does. Doesn't seem to do anything. I'm definitely in the coil. Don't know what this does. This might be adjusting high voltage maybe. I'm not going to adjust that much. I'm going to take that out of there. Yeah, it doesn't seem to do anything. Now, part of my problem is that it feels that this is still too wide. There's a horizontal control on the front, but this is more like horizontal hold and vertical hold. So let me just make sure I'm at the extreme end of this width coil. Problem is it's got a core inside, and if you do it too much, the core can fall out. Oh no, it's getting smaller still. All right, it must be at the end because it doesn't really seem to do anything now. So the core is like moved out of its its effective range. Well, it's better. It is better. You have to remember that originally this was designed for use with like cameras and stuff, which had overscan, so you really weren't supposed to see, into the border region. Now the CGA card that we have hooked up to this, of course, every card's going to be a little bit different. Every computer is going to be different with the amount of border region it has. CGA has 640 pixels across, but of course, video signals like this, that's completely arbitrary. You could have 1,000 pixels across and it would work. Wouldn't change anything to do with the video signal because all that matters on the video signal is the scan rate. So the amount of time between each horizontal refresh where the beam goes back and then also the vertical scan rate. So 50.7 kilohertz on the horizontal and 60 on the vertical. You can draw as many pixels as you want as long as you do it in the right amount of time. It doesn't matter. So the card can output any arbitrary amount of pixels, and it all just depends on the way that the main chip is. I should put the regular CGA card in this thing, and we should just see if this looks different, like if it's shifted at all, which it might well be. It might be in a different position. It might be more that way, it might be smaller. Let's take a look. Let me grab the IBM CGA card. I was using this VTech card, and the thing about the VTech card that I really like is it has 2 RCA outs. One is color with artifact color, and the other one is just a nice solid monochrome shade, which is the one I had hooked up. That way, when we were in edit and programs like that, everything looked really good. This card has just composite out with artifact color, so everything pretty much looks terrible on it if you're trying to look at something like the edit program. And I'll show you exactly what I mean when this thing boots up. I think what I'm going to do, though, for sure, is I'm going to leave this CRT in here. I'm happy with the way this looks. Looks good. Interesting, as this seems a little bit darker than the other one. So the output video signal, like, levels are going to be different from one card to another, of course, as well. This has snow, so you can ignore that. That is just the CGA card. That is completely normal. Yep. There's that IBM CGA snow. Okay, there we go. So let's see, vid test. Vid test. It's funny typing sideways. Yeah. Okay, so the solid background now is made up of vertical stripes because, of course, artifact color. I don't know if you could see that. Let me get this in focus. Yeah, I think there we go. Either way, we were looking at crosshatch 4. Is it different? I think it's shifted more that way than it was, isn't it? Yeah, I think that's the case. It would be nice to move it down, and you can do that with centering rings. That's on the deflection yoke itself, which I happen to have an extra deflection yoke sitting right here, so we can demonstrate that. So these are the centering rings, these things right here. So you just turn these, and that will move the image, and there are 2 of them, and they affect it and move it up, down, left, right, and stuff like that. And then as for these little magnets, which I'm going to take off this deflection yoke, I'm going to transfer them onto this one that's on here. This will allow you to correct for any kind of like bowing and stuff that you have. I gotta get this aligned because it's with the monitor on its side, it's tricky to do. But this allows you to, like, you turn these and then you can adjust the bowing and if this goes in or the corner goes out. So this has 3, and the other CRT, that's got some on it too. I might steal some from that if I need to. So yeah, okay, this one had 3 I took off of there. All right, I think what I'm going to do, let's see, I just need to get my bearings. I think what I need to do is I need to get the CRT properly bolted in because it's loose. Now, one thing I'd like to mention, we'll just turn the lights back on, is that if you have a CRT and it's slightly out of kilter, what you could do is if you don't feel like loosening the yoke and turning it, you can actually loosen the fasteners on the CRT, and there's a bit of adjustment in that as well. So you can get a little bit of, you know, if you need to straighten it and you don't want to stick your hands inside of a running CRT, try loosening the fasteners a little bit if you can access them easily. It's not always easy. Loosen them up a little bit. See if you can kind of give the CRT a little bit of a twist or move it into the position that might get your image centered in the bezel as best as possible. Like there's always usually a little bit of adjustment range in the fasteners for the CRT. So with this one here, I'm just trying to like push it up kind of into the, I don't know, what seems like neutral position, I guess. And I guess what I should do is put this front bezel back on. So there's this plastic piece here. This bezel sort of clamps on the top here, and you tilt it on. Okay, let's turn this on and see how it looks. When you have it against the bezel to kind of compare, it gives you a better idea of how much rotation you need. I'm happy with that. I mean, you can never really get it perfect. That looks pretty good now. Now, the corner is going up in that corner. All the corners could use those little magnets. I only have these 3, so let's pop one of them on and see if I can fix that corner. I'll turn this off to do that because I got to stick my hands in there again. And I'm going to steal one off the other set. And I noticed the other set has like stacked. Some of them have 2. So that means that it had to really correct for a little bit of a geometry issue. All right, let's see what we can do now. So I just put them on randomly so they're not in any particular position. Therefore, I don't expect it to be any better or any worse. If anything, it could be worse. Okay, it's worse in that corner, that's for sure. So let me get my hand in there. It'd be easier if the top wasn't on here. Okay, so if I turn it one way, see what it's doing there? We turn it the other way. Not bad. Now you can put one in the middle too, and that will pull this out a little bit. That can help. Let's do this other corner up here. Ah, yes, there we go. Better. Not perfect, but it's a CRT. It's never gonna be perfect. It's an analog thing with magnetics. Like, what do you expect? Now I'm in this corner down here. Oh, that's what, way worse. The middle could be pulled out a little bit. I'm gonna grab another one from this other CRT on the floor here. This only works on monochrome CRTs, by the way, because if you tried this on a color CRT, you would get all sorts of color purity issues, like the red would change to green and blue. But on monochrome CRTs, it doesn't matter. Little magnets like that are how you do these fine adjustments. This is looking, well, this is in too much now, right down there. And what I'm gonna do after this, by the way, is get my little hot glue gun out. And I'm gonna put a little hot glue on there. And the hot glue will just keep those from moving anymore. Now you really have to look straight on because the curvature of the glass can trick your eyes a little bit. And now when I look straight on, this looks like it's bowed a little bit. I think I might have just dropped one of the magnets off inside. So one of them fell off as well. All right, well, I'm gonna spend a moment to fiddle with this, get the hot glue gun out and get this adjusted, and then I'll come back. Well, it's actually been a few days and I've been using this monitor and, well, it is working perfectly. I'm very happy with this white CRT that's installed in this monitor. Let me turn on the Apple IIc here so you can kind of see exactly, well, how it looks. And it looks, frankly, great. I have zero complaints and I so much prefer this over the green CRT that was in here. Even if it's not quite as sharp, it's still a better experience. I think just because I'm looking at what is a security camera monitor and I'm fully expecting it to be a white phosphorus CRT, and that's what we got. Let's get up close and personal, and there it is. It looks really good. Of course, this is hooked up to an Apple II, which means it's a monochrome output. That means every single pixel that comes out of this computer is either white or black, and that means any kind of that DC restoration stuff is not any kind of an issue. Although, I have to say, that DC restoration circuit on the back with that switch, it actually does work. And I realized that the way it works, when you look at the schematics, is I think it has something to do with the sync tip. Basically, it's looking for compliant NTSC video signals, and a lot of old machines don't produce a perfect image. And it turns out that VTech card I had plugged into this thing, it did not produce a correct sync pulse. Even though the monitor obviously had no trouble syncing to it, that DC restoration feature didn't work super great. When I had the IBM CGA card hooked up later, I noticed it was actually working perfectly. And if something changed between like a really bright image and a dark image, you could actually see it do the little bit of adjustment. So when it went dark, you'd actually see a little bit of the scan lines and then they would disappear. The Apple II doesn't quite seem to do that totally perfectly, but it's really not an issue. So for instance, we don't have any scan lines here. And if we exit out of this, no scan lines. And that's mainly just because it's monochrome signal. So you can just turn the brightness down and then turn the contrast up so everything looks really good. And any kind of slight variability, you just don't notice. But there is a little bit of variability. So I'll turn it up so now we can just see the scan lines. Sorry for the reach. I gotta reboot the computer here. Now the scan lines have disappeared because there's all this bright content on the screen. And if I exit out, there, the scan lines came back. But you just turn the brightness down a little bit and it's really not any kind of an issue. Now, one thing I did do on this is I actually removed, and if I just move this extra deflection yoke, I removed the handle that was on top of this monitor. The one that was there, it was this rubber handle here. And unfortunately, it's like fake leather and it's turning into an oily, disgusting mess. So that's going into the trash. And on top of the sides were these like metal clasp things. I think you could probably still buy these, but these are all sort of rusty. And there's two of those. So those are going away as well. And that did leave some holes where I removed those clasp things and it was all kind of rusty and gross as well. And even though I cleaned it with Magic Eraser, it never became totally clean. So a couple stickers on there, it covers that up without issue. I'd probably just leave it normally, but I don't really want things potentially falling down into the monitor. I love that this is flat on the top and it's pretty deep. That just means you can stack things on top of this monitor. You're not left with something that you can't put things on. I mean, I could even put that Apple IIc on the top of the computer and it would work, which is great for a show or whatever if I'm bringing this thing around with me. And then the final thing that was a bit of a problem with this monitor was the back cover, and you saw that it was extremely rusty on the inside. Well, I went ahead and I took care of that. I mean, took care, it should be in quotes, I took the wire wheel brush and I really got a lot of the loose rust that was on this part of the back chassis off. I didn't get rid of all of it, but I got rid of a lot of it. Then I put some navel jelly on here, which is like a really strong phosphoric acid to eat away at the rust. And it did for the most part, although it did leave some behind. And then I just sprayed rust converter on it. That's what this black paint is. So on the top here, there was a bit of rust and on these bottom edges. So anyways, I just sprayed it over the whole back and you know, it's fine. I mean, the back of the monitor isn't in perfect condition because that rust is starting to bubble through like in spots. But to be honest, you don't really notice the fact that I spray painted that black paint except for like some spots like this and right here. But I really don't care. This monitor is in rough shape and this is a lot better than how it was. All right, the back cover is back on. Let's just make sure the monitor still works. I mean, there's no reason why it shouldn't. Yeah, there we go, looks good. One thing I forgot to mention, when I was just doing the final adjustment with those little magnets around the deflection yoke, well, I went to go adjust the centering rings just to recenter the image because I felt it was off to one side a little bit. Just make sure the focus is good. Well, and when I was doing that, they were very difficult to turn and they broke. Well, one of them broke. This one is still in shape, in good shape, but this one here snapped. So I thought, well, I could try to glue this back together and it would probably work fine. But then I realized that the CRT that I had for going in here actually had the deflection yoke from whatever it was originally in. I don't really know at this point. I do typically keep these just in case I end up with a monitor that has a bad deflection yoke. Maybe the inductance is close enough that I could use this if, say, the one on this one died. I didn't even test that. So I do hold on to these. But anyways, it had the centering rings on here. And I just took them off, popped them off, and popped them onto this, and yep, they worked just as good. These ones are made out of some kind of material that breaks, but the ones that were on this, which I borrowed it from permanently, they were metal. And it had this little spring apparatus between the two, just to kind of give them some friction, but the design of this yoke's a little bit different than the design of the yoke that's on here, and just clipping them onto this, well, it squishes them together, the plastic does, and keeps them really kind of hard to turn. So they won't turn accidentally. So I'm just gonna keep this little spring clip thing on here, and I have the little clamp thing that goes on here, so I'll just reassemble this, throw it into my box of deflection yokes. And as for this broken one, I'm just gonna throw that away, but I will keep this extra one here, because you never know. You just might need one of these at some point in the future, so I'll just clip that back onto here. Oh, yeah, just like that. So there we have it, just like that. I am done with this video, and I think I'm gonna be bringing this monitor up to VCF in Seattle with me because it's nice and boxy, and it's also, of course, very durable, so it's perfect for that. And I feel it's gonna be perfectly reliable to be on all weekend and hooked up to something showing off stuff, things that I'm gonna be showing off. So yes, just in case you are unfamiliar, I'm gonna be up at VCF in Seattle. It's in, I think, by the time this video comes out, maybe 4 weeks from now or so. So if you're in the Pacific Northwest, I highly recommend coming and checking out the first VCF in Seattle that's been happening since pre-human malware days. I'll put a link in the description below for information on that. I'll also be at VCF in Dallas, which is at the end of May, and I'll be in Chicago for that VCF Midwest. I think that's in September. So those are the 3 that I'm going to this year, and I'd love to see you at one of those. So there we go. That was just a little bit of me fooling around with a monitor and doing a swap. It's like nothing revolutionary going on here, but I just wanted to kind of show that this stuff is possible, and I'm really happy with this swap. And it's made this a better monitor, and to be honest, this monitor where I found it originally was in the trash, which is why it's all beat up and rusted, and obviously it was thrown away because it was so burned in and the CRT was just completely shot. But it's amazing that the rest of the electronics, I never touched anything. I didn't recap it, I haven't done anything to this thing, and it just works flawlessly. Absolutely perfect. So anyways, that's gonna be it. Thumbs up if you liked this video, thumbs down if you didn't, comment down below. Huge thanks to my supporters. Thank you for subscribing. If you haven't already, hit that subscribe button, all the other usual YouTube junk, and I guess that's gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye. Boo.